we'll do a quick little intro here on me and then on HardHat. Been a consultant here at Spectre Ops for about a year and a half. HardHat was released back in March of 2022. And I, am a red team operator, do tool development, and work on the adversary simulation team here at Spectre Ops. So what is HardHat? HardHat is a multi-user, multi-platform command and control framework. It allows you to, you can set up your team server and your client on any operating system. Every user gets their own client, and then you share a team server to connect in and run ops. The goal of HardHat is to keep it extremely simple, but also robust. To start the team server and the client, you run 2 commands, and then you're good to go. So there are a lot of features that didn't make it into this talk. Here's a list of them. I'm not going to read through all of them, but some big ones are stuff like SOCs, role-based access control, sleep encryption, as well as event tracking and credential stores, all the stuff you'd want from a modern C2. So the big first feature I kind of want to talk about here is asynchronous commands. All of the commands of HardHat are asynchronous. So you can start a command, it can run for 2 hours. You can run a command you need right away, and it'll give you feedback well before that first command has a chance to come back. It also allows for multiple .NET binaries to be ran in memory at once, and they can be loaded into different app domains, so that way they don't step on each other. This allows for you to execute something like sharphound or Rubius, or you can set Rubius to like monitor, and then you can also go and do like ask TGT and pull back stuff right away without having to worry about stepping on the current execution that's happening. Commands can also be set to run synchronously. If you want to, change directory and then list your current directory, you'd want to run those synchronously so that way one happens before the other. Quick little video here, basically just showing off the asynchronous nature of commands. So we'll run Rubius inline with monitor, and it will be able to stream back data while it's running. And we'll also be able to execute other commands while that's happening. You'll see the kind of spinning circle here will turn green. That means that we got back data from that command. And you can see there it is now currently running and monitoring for new incoming traffic. While that's still executing, we can run klist to go and see that information on that response there. Cool. So the other big one is local terminal logging. When you're opping, you may want to proxy a lot of commands because you may not want to run stuff on system or even in memory on target. You may want to run something like Certify. You may want to run an impacket tool, and you want to be able to proxy that in. But when you're proxying that in, you don't normally just get like logging. You don't get, timestamps. You don't get the ability to track it and mark it in your C2 because it's usually happening outside of your C2. With HardHat, you can spin up as many local terminals as you need, and then those all get logged, monitored, and can have pre and post processing done of them as well from inside the C2. So we'll do a quick little video here showing that off. While that's running, the terminals are unique per person. So if you have a terminal, other operators can see your commands that you're running and see your output, which also means you don't have to sit in a Zoom call, share your screen, and be like, yeah, here's how I'm running Certify. They can just see it. But they can't run commands on your terminal. If someone inputs a command in a terminal window, it will only run on their local machine. So you can see here, we go and we run impacket into ML relay X. We get the output there, and then over on the other terminal window, we can also fire up something like PSExec and get that output as well. And now that's there, it's logged. You shut down your team server and restart it, you still have those command outputs the same way you would with an implant. The third big feature for HardHat is dynamic implants, the ability to dynamically compile an implant, pick and choose the commands and modules you want to include. So with the engineer implant, you can pick what commands and what modules like sleep encryption or data chunking you might want to include or not include with the implant. Quick little video here showing that off. We'll go and we'll pick out some commands to include and not include, and then we will dynamically load a command during execution. So while a implant is running, you can decide to push a module. Like you may want to start out with no sleep encryption, and then you may be like, you know what, this is going well. I want to add sleep encryption to my implant. You can push that and it will get activated. You can also push new commands. Like you may decide, oh, I don't want process injection when I initially start up my implant. And then later you can push process injection commands to the implant and have those executed. So here in the video, we can see we picked out some commands there on the right to include and others that weren't included. We'll then go and execute that implant, and we'll be able to push a new task to it with the add command or add module command. So first we'll execute who am I. It will say that it can't find the command. We'll then run add command to push who am I onto the implant and then execute it and actually get back the output we expect. So we can see here that who am I failed to execute. We then go to run add command to push it, and then we'll run who am I and actually get back the output once add command is finished. So we can see here that add command successfully finished, and then who am I will actually execute and give us back the result we expect. Cool. The other big thing that HardHat offers is task read status. If you have 10 different implants running, you may only have 2 of those open at one time, and other operators might have other implants open. They might be running commands and getting back task results. And you may not know, like, have I read those task results yet? Have I not read those task results yet? Did I start 3 commands overnight and then go to bed and not actually read them in the morning? HardHat allows you to essentially keep track of what commands you've read the response on and which ones you haven't. So we'll see here, these 4 commands were executed, and those little orange dots there basically mean that you haven't actually opened that panel to read the result data yet. You can also see this from the list of implants on the main screen, meaning you know when someone else has executed a command on their own implant and you want to go and read that tasking data. And as you open and close them, you can see how many commands up there at the top have been unread, and you can also see those dots clear once you've read that task. And you can see here, for example, this one has 2 unread. As we scroll, you'll see ones that have 0, and you'll have ones that have 1 or 2 commands in there, and you can go through and you can read that data. So you'll be like, I missed this one. So let me open it and see what the result was. In that case, it was empty, but it's still good to go and check. Another thing that HardHat offers is a unique file browser experience. The file browser in HardHat is persistent. It is shared between all of your implants. That way, if you have an implant die, you don't have to relist all of your directory data. It's just there, and you can go and you can browse with it. It's persistent between implants, and it's persistent between restarts. All that data is stored in the database. So that way, if your team server or your client needs to be restarted, you can do that without having to worry about missing out on data. We'll do a quick video here to show that off. When you run an ls command, the results from that are populated into the file browser, and also vice versa. When you browse to a location with the file browser, it will get replicated into your terminal output. That way, if a coworker is browsing a whole bunch of file shares and you just want to see the output in the list, you can go to the list and look at that output that way. So you'll see here, we'll select an implant to browse, we'll look at the file browser. Golden colored photos or folders like that mean that you've read that data or that there's tasking data there for you to read. Once you click on it, it will become dark in the center, meaning you've opened that folder. You can also go to the top bar up there, kind of like you would in Windows. You can type in the location of a location you want to browse to, hit enter, and it'll go and get that data for you. And once it gets data, the folder over on the left will update to that same kind of golden color, meaning you know there's something there for you to go and look at. So you can see here that folder there populated, and now we can click on that and we can look at the content within it. And all of that is also replicated over to your implant. So we should be going back to the implant here in just a second. Oh yeah, the file browser, you can also search through it. So if you're like, oh, I just want Python files, you can search and there's all your Python files. Yeah, it'll allow you to search. You have symbols and all that great stuff. So we'll go back to that implant, and now you can see that ls public command that I ran from inside the file browser is now present there in the implant. That way, coworkers following along can just look at it this way and not have to keep up with where you're doing file browsing at. Next big thing is the file preview. When you download files off of a client's device, like a zip file, a PDF, or an image file, you may want the ability to preview those images or preview the content of those zip files without having to actually download them all the way to your local client and then open them on your machine. So we'll see here that I've downloaded both a JPEG and a PDF file, and we'll go over to the Downloads tab. And there's both a download option and a view option within the download tab. The download tab tracks the name, the host, the pathing location where you saved it, that we have all that relevant kind of data. And with the viewer, you can go and you can preview that image right away from the C2. You either have to download it locally to your client and then see it that way. Same thing for PDFs. So you can go and pull up a PDF and you can browse it that way. This also works for zip files. So I zipped up those two files and put them inside of a .zip, which normally you'd have to download, uncompress, pull out the files, and then look at them that way. Here, you can just click on them and they will render on the right side there. I'm looking to add more file types, such as like Word docs and things like that. I need to get conversions to PDFs going, but once that works, it'll let you do the same kind of thing with lots of different document types. Next thing is command aliases. Command aliases allow you to take a long string and replace it with some sort of shorthand. They just start with $HH underscore. And then they can also be nested. So essentially you could do something like a long inline Rubius command, and you just say, underscore HH inline Rubius, and that'll expand out to your long task. This can also be really nice for storing stuff like base64 tickets, passwords, or complicated commands that you don't want to have to type out or copy and paste. Run through a quick little example here of making an alias and then going through and adding it and executing it. We'll make one executing Rubius inline. So we've now added that one there, doing Rubius inline, which will expand out to that inline assembly, blah, blah, blah location. And then we will do Rubius inline klist, which is the argument we want to pass. So you can nest aliases inside of each other. So the beginning portion of that value there will be that original inline. And then next we'll pass in the rest of the command I want to run, which is args klist. So when that expands, it'll tell our implant we want to do inline assembly at this location, this command. And once executed, you can see there it expands on your command panel. And once executed, it gives back the results the way you'd expect. So some things that I want to add into HardHat in the upcoming release. Big one is third-party implants. I've basically rewrote a lot of the team server and client to allow for the ability for other implants to talk to HardHat and be built in HardHat in other languages other than just C#. So now third-party developers can build implants in other languages. They can allow those implants to talk to the C2. They can customize how the C2 processes that data, how it compiles those implants, and how it handles pre and post processing, displays in the client. And eventually this will get expanded to allow plugins of anything to happen within HardHat. They can build plugins for things that I haven't even thought of as features yet. Currently, it does require a little bit of C# code to be written by another user, but I built a Rust demo implant that only took about 50 lines of C# code to go from this can't talk to HardHat at all to this is now talking to HardHat. Quick little video here showing that off. So we can see currently we only have the engineer there within inside our build. We'll run .NET build on both of the plugins. We'll copy them over to the plugin folder while HardHat is still running. And once they're copied over and HardHat is refreshed, we'll then be able to see the demo Rust implant inside the menu here. So we'll refresh both those plugins just via the settings there. We'll go back to the build menu and we'll find that now we have the secondary Rust implant with a different creation menu. We'll go through, we will compile that Rust implant, it'll be able to check in and speak to HardHat, and we'll be able to execute commands on it. Currently, HardHat provides a default implementation for almost all of the team server and client processes that someone would need to do to talk to HardHat, but they also have the ability to fully customize those as they desire. And there we go. We'll see that now that Rust implant has checked in, and we'll execute a simple who am I command and get back that result data from it. The other big thing I want to add in 0.3 is objective tracking and tagging. So you'll be able to make a list of objectives. Each objective gets a tag. You then put a tag on a command. And then later on, you can filter all of your implant's tasks by that tag. So for example, if your tag is to like privest in a domain, You might then filter every single command to privask in that domain and see all of them in that list together to build a like chronological timeline of action. So here we'll head over to the objective tab and we will make a quick little objective, and then we will tag some commands with it. And from there, you'll be able to filter those commands within the objective view to see what commands were relevant to your objective and which were just extras that didn't really matter at the end of the day. We'll fill in some subtasks. So a objective can have a list of subtasks for you to complete. It has a status, it has a name. You can check off those subtasks. And when you execute a command on an implant, you'll be able to go through and flag those commands by using the tag icon over there on the far right. You'll click that, you'll pick a tag from the dropdown, and then from there, you'll be able to customize that and be able to filter it. So if we go back over to the objective menu here, you can pick out your tag, and then all of your tasks with that tag are now present. You'll also see here when we run a secondary command from a totally different implant, and then we put a tag on that command, and we go back to the tagging menu, both of those commands will be present underneath that tag. The last thing I want to show off is data chunking. The engineer will now have the ability to break down tasking data into very small bite-sized pieces. If network traffic size is important and you're worried about offset considerations when you're sending data outside of your client network back to your C2, you may want to limit the amount of data per check-in. That's all I've got. Any questions?